So get out the little note thing that I gave you, and that's going to help you answer these questions.
I didn't get one.
That's true, you did not. That's for you. Right, the first one says it doesn't just vary directly, it says z varies jointly with x and y. So that means z equals k times xy, okay? It's varying directly, so that's why the k is there and that's why we're multiplying, but it says jointly, so that means it is both an x and a y together.
Did we
Okay?
learn this?
Yeah, sure you did. And then it says that z is 30, x is 3, and y is 2. So I'm going to plug in 30 for z. What was x? 3. And y is 2. So what does k equal?
5.
5. So final answer, z equals 5xy. Okay? It varies directly, so you know you're multiplying. The only thing that's different than what's on the notes that I gave you is it's not just x, it's x and y. No big deal.
Why isn't the answer 5?
What's that?
Why is the answer not 5? Why is
That's only part of the answer, but the answer is the whole function.
it?
Okay? All right, now things get even trickier. It says for number 2, z varies directly with x and inversely with y. Okay? So what?
Z equals K.
Z equals kx. And then where does the y go? No, one equation. Underneath, yeah, because inversely means the y is on the bottom. So z varies directly with x, so that means z equals kx. Inversely with y, so z equals k over y. So that's what you get. Okay? Then once again, to figure out what k is, plug in what we know. So z is 30. X was 2 or 3? 3. And y is 2. So if you solve that for k, what do you get? K equals 20. So my final answer for this one is z equals 20x over y. The microphone is in the laptop.
That's just too bad.
Pretty twice. Okay, then number 3 says z varies inversely with the product of x and y. So inversely means
X and Y are below the K.
x and y are below the k. And then once again, plug in what we know. Z is 30, x is 3, y is 2, so k equals 180. So final answer, z equals 180 over xy. Pretty easy?
Well, it's just like when you go through it, it's
Oh.
it helps me
Yeah.
understand it because I'm not.
You have to prove it tomorrow on your own. Oh. Make my test multiple choice and have the answers all be A. You wouldn't get 100% then. All right, number 4. Direct, inverse, or neither. How do you know it's not direct? 22 times what? They're both going up, but if they're both going up, then it could be direct. So the fact that they're both going up means you know it's not inverse.
Then you need to go by the same amount.
Well, no, but it needs to be,
When you divide
X
Well,
it,
I mean when you divide them.
yeah, right, okay, so when you divide them, so if we go 104 divided by 22, what do you get?
4.7.
4.7-ish. And then when you go 174 divided by 35, what do you get?
4.9.
Okay, so these are different answers, okay? So you can't multiply the x's by the same thing each time and get a y, and so that means that this is neither. Okay? How about number 5? First thing you might notice is that the x's are going up and the y's are going down because they're getting to be bigger negatives. But this is a weird thing. I don't know why this works out this way. What is negative 4.8 divided by 2?
Negative 2.4.
Okay, so if we divide the first ones, we get negative 2.4. What do you get if you divide negative 14.4 by 6? Negative 2.4. What do you get if you divide negative 28.8 by 12? Any guesses? Negative 2.4. And what do you think you're going to get when you divide negative 45.6 by 19? Negative 2.4. Okay? So since you can take the x's and multiply by negative 2.4 each time and get the y's, that means this is an example of direct variation. It's a negative thing that switches it and makes it do something. All right, how about number 6?
How do you check if it's inverse variation?
How do you check if it's inverse variation?
They divide.
What? You multiply, yes, good. So you divide for direct, you multiply for inverse. So what is 15 times 2.4? 36. What is 18 times 2? 36. What is 20 times 1.8? And what is 45 times 0.8? And I'm going to assume you're correct. So since they multiply together to be the same thing every time, that is an example of an inverse variation. So if you want to add some notes onto the notes that I gave you as we go through, feel free. Okay, ready? All right, number 7. Now they're telling us that they vary inversely and we need to come up with an equation. So what is the general thing that an inverse equation, inverse function looks like?
X, Y equals K.
You can go xy equals k, or you can go y equals k divided by x, okay? But the xy equals k is not a bad thing to know because that's going to help us figure out what k is. If they vary inversely and you know that x is 13 and y is 17, what does k equal? Yeah, you go 13 times 17 and get 221. So my equation is y equals 221 over x. So to find out what k is for inverse variation, you multiply. To find out what k is for direct variation, you do what? Divide. So that should make number 8 really easy. What do you get when you multiply those two numbers together? Negative 48. So my answer to number 8 is y equals negative 48 over x. And same thing for number 9. What do you get when you multiply those two numbers together? Negative 13. So what's my answer? Y equals negative 13 over x. Okay? Okay, we good? All right, number 10. We're starting with the graph 4 over x, and then we're comparing it to the graph of 9 over x. What happens when you change that 4 to a 9?
It's stretched.
Yeah, that is a
Right,
vertical
2.5.
stretch.
2.25.
Vertical stretch. And Miranda said she's an overachiever, went 9 divided by 4 to find out exactly what the vertical stretch is. It's true, you're not. Okay, how about number 11?
It goes
If you start with 1 over x and then you change it to be 1 over x plus 5, what do you do to the graph then?
Change to up.
Up 5. And number 12. This is a little bit tricky. What? Left what? What did I do with the x minus 1 to get the x plus 1? Added 2, right. So since I added 2 underneath, that means, yeah, left 2. So this one I added 2 to get from there to there. What did I do to get from the plus 2 to the minus 2 there?
4.
Plus or minus? Subtracted 4. So subtracted 4
Is down 5.
equals down 4. So left 2, down 4. Okay? Got it? Huh? Okay. 15. What do I have to do to find holes or vertical asymptotes? Where do I find the factor? What you said before? Yeah, I got to factor the bottom. Two numbers that multiply together to be negative 10 and add to be 3 are 2 and 5. And it's going to be positive 5 and negative 2. Okay? So that means x equals negative 5 or 2. Okay? Are either one of those removable? No, because I can't cancel them. So that means that these are both vertical asymptotes. Okay? I know. How about non-removable discontinuity? That's pretty long. Same. All right, how about horizontal asymptotes? What does it say on your notes for that? Okay, so highest power on top divided by highest power on the bottom. The power on the bottom is bigger, and so what does that mean is true? Hello, Little Rich. Hey, how's it going? Hit the pause button. Say that one more time. So we've got the highest power on top and the highest power on the bottom. So we get 1 over x squared, so what does that mean? 0, right. Since the power on the bottom is bigger than the power on the top, that means y equals 0 is a horizontal asymptote. Any fast pitch players that watch this video, I don't know if any of them actually will, but this could be what life is like without fast pitch players in class. So glad. We'll get done with this soon. Oh well. All right, 14. They have nicely factored this for us already. Yes, exactly what Miranda said is true. Since the x plus 2, you could cancel those. That means that x equals 3 is the vertical asymptote. We'll get there in a second, but the answer is no. What is x equals negative 2? That's a hole. Okay. And then Anthony wants to say that the horizontal asymptote is at 1 because the highest power on top is x, highest power on the bottom is x, and they cancel and give you 1. But that's not true because why? Right, I would need to actually FOIL those out. I don't really have to, but just to recognize that I actually have an x squared on the bottom, So I'm going to go x over x squared, and again, just like in the other one, since the power on the bottom is bigger than the power on the top, y equals 0 is a horizontal asymptote. Okay? Easy peasy? Yes? Yeah, Amy? You get too quiet, you go freak me out a little bit. Can I turn the page? All right, so what do I have to do to start this? Factor it. So two numbers that multiply together, are they both -1? Yeah. So that's fun. What's going on there?
It all cancels out.
It all cancels out? Just one of them does?
Oh.
I don't know. 15.
Don't ask me.
Just one of them. So those cancel. So at x equals 1, what's going on?
Vertical asymptote.
Vertical asymptote.
I call it VA.
Uh-huh. I'm going to write the whole thing out so that you're not confused, but
And then one's the whole.
right, and since there's already a vertical asymptote there, there can't be a hole there. The vertical asymptote beats out the hole. It's like rock, paper, scissors. So yeah, that is confusing. That is a weird one. But you can't have both the vertical asymptote and the hole. The vertical asymptote is like stronger or whatever. What's my horizontal asymptote?
0.
Y equals 0 again. It's the horizontal asymptote.
Sometimes the horizontal asymptote will just have something that will make it, like, actually have,
I know, I feel the same way. I feel like the horizontal asymptote is pretty good with that.
I like the horizontal
Like that.
So you like y equals 0? Too bad, those glory days are over. Brandon called it. The limit does not exist. Okay, so what do we have going on here? X equals -2 is a what? Vertical asymptote. Yeah, and then there's no holes because that won't cancel. This time, right, y equals 5 is the horizontal.
How do you get that?
How do you get that? Yeah.
He's waiting until it's worked from this.
Yeah, you go 5x over x, the x's cancel, so you get 5.
Okay, I believe you.
Do ya?
No.
Well, let's do that. I've been teaching you wrong this whole time. All right, we're not going to make it, are we? Okay. Well, let's do, oh no, we'll do some graphs. And then let's do some of the graphs and then see where that takes us. Okay, so number 17, y equals -2 over x. We'll just make a little sketch. What's it look like? Top left, bottom right.
Are we ever going to have to graph it with a sketch?
No.
Okay.
Top left, bottom right.
We have to do W and on that one?
Yeah, what are they? -infinity to, there's a hole right here in the middle, so to 0, and 0 to infinity. What's the range? Huh?
The same thing.
Same thing, -infinity to 0, and then 0 to infinity. One for each branch. Okay? So that's our most easiest basic graph. Ready for another one?
No, hold up, wait a minute, put a little love in it.
I'm not.
But Jason he's a stalker.
Calvi's class comes over here, slows us down. So that's kind of stretchy. All right, so now we are taking that graph that we did in the last one and we are shifting it a little bit. The x plus 3 on the bottom moves it to the left 3. 1, 2, 3. The minus 4 here does what? Move it down 4. So where are my two branches?
Right here.
Bottom left, top right. How come in the other one they were in different
This
places?
is negative.
Because it was negative. Okay, so the domain, so we're talking x's. Negative sideways 8 to negative 3. Negative 3 to infinity. How about the range?
Negative 3 is negative 4. And negative 4 is
Negative 3 to negative 4 and negative 4 to infinity. All right, number 19. That color looks what? You were thinking that?
That's the color.
Okay, what do we do? Factor the top. X squared minus 9 factors into what? X plus 3, x minus 3. Factor the bottom. Okay. So, what's going on at x equals negative 3? What's going on at x equals negative 3? There's a hole in the graph because those two things cancel. What's that? What's not negative 2/3? Oh, I see what you're saying. No. Because if you set that equal to 0 and solve it for x, you subtract 6 divided by 2, you get negative 3.
I don't know the whole
Okay. Well, we'll show you in a second. All right. How about what's going on with the y? What's the highest power on the top? Right, x squared. What's the highest power on the bottom? So if the power on the top is bigger than the power on the bottom, what's our horizontal asymptote? There's none. Okay? And so here's the way that you graph these. We've canceled the x plus 3's, right? So that leaves us x minus 3 over 2, which I don't want to freak you out or anything, is the same as x minus 2, or x over 2 minus 1.5. So what kind of a graph is this? A linear graph. Yep, absolutely right. What do you know about that linear graph? Okay, the y-intercept is at 1.5, so across the y-axis right there. What else do you know about it?
3 is
What? Yeah, what's the rise? 1, good, 1 over 2. So from there I would go up 1 over 2, and then up 1 over 2.
Where did we learn this?
In elementary first year algebra, how to graph a linear function.
No, I mean, when do we learn about...
Oh, we haven't done this in this class. And then at x equals negative 3, there's a hole, right? So when I continue this line right here, when I get to x equals negative 3, I need to put a little hole in the graph.
Is that going to be on our quiz?
I hope so.
But you just said we have it.
No, you learned it in algebra class. You know how to graph this. Y equals 1x over 2 minus 1.5. Y equals mx plus b. The only thing that's different in this class that we added is that x equals negative 3 is a
And
hole.
then negative 2. Oh, I know.
Okay? What else you get?
I don't... It's 1 over
Yeah, just go.
Okay. I'm teasing you a little bit, Miranda. That's a little tricky, isn't it?
Well, we didn't learn it, right?
Yeah, we did fine.
Usually we didn't learn it.
No kidding. Well, not this year.
Maybe we talked about any of that stuff.
You're right, but now we have. Okay, so what can I factor out of the bottom? X. What will that leave me? X squared minus 1. Well, that's fun. What does x squared minus 1 factor into? X plus 1, x minus 1. Okay? So now I have 3 things going on with the x's because I factored this into 1, 2, 3 separate pieces. Okay? What's going on from this plain old x by itself? 0. And what is x equals 0? Is it a vertical asymptote or is it a hole? It's a hole because this x and this x can cancel. Okay? So there's a hole. What's going on at x equals negative 1 and 1? Vertical asymptote. And then what is my horizontal asymptote? Nope. Power on the bottom is bigger than the power on the top, so that means it is 0. Okay? So vertical asymptote at x equals negative 1. Vertical asymptote at x equals 1. And then the horizontal asymptote at y equals 0. So now we need to know what's going on, and I tried to explain this to you before. There's either going to be a branch here, a parabola there, and a branch here, or there's going to be a branch here, a parabola there, and a branch there. And the way you find out is you take the original thingy and you pick a nice easy number. You can't pick 0 because 0 would be 0 on the bottom. Yes, so let's do 1. So if I plug in 1, I get 3 over, uh-oh, I can't do that either because that's one of our asymptotes. 2. Okay, so that would be 6 over, oh good one, 2 cubed is 8 minus 2 is 6, so that's 1. So when x equals 6, which is over here, y equals 1, so that means you know that one of the things is in this branch right there, okay? And then I have another one going on here, but at x equals 0 there's a hole, and then I have a branch over there, okay? All right, so you can try and finish that tonight if you want. At the beginning, at the beginning of class tomorrow, we'll go through the last, how many problems together? 1, 2, well, 8 of them together. And then we'll have a quiz, okay?